The unseen war. Your body is a fortress, a planet of nearly 40 trillion cells, constantly under siege by invisible enemies. We're wading through an ocean of viruses and bacteria with every breath we take and every bite we eat. In fact, a study from Singapore found that humans can inhale between 100,000 and 1 million microorganisms a day. So, why aren't we sick all the time? What is this internal army, and how does it fight a billion-front war to protect you 24/7, often without you even knowing it? Every single day, you are in a war you can't see. Trillions of microorganisms are all around us, in the air, on surfaces, and even inside our own bodies, which are home to an estimated 38 trillion microbial cells. Most are harmless, some are even helpful, but a determined minority views your body as the perfect territory to invade and conquer. These invaders are called pathogens. Think viruses, harmful bacteria, and fungi. Their goal is simple: find a home, multiply, and spread. Your body's goal is even simpler: stop them. To do this, it relies on one of the most sophisticated defense networks ever conceived: your immune system. It's not a single organ like the heart or brain, but a decentralized network of cells, tissues, and proteins. Think of it as two distinct branches of the military. First, you have the frontline infantry, an immediate, brutal, all-out assault force. And second, you have the elite special forces, a slow, calculated, and highly intelligent counter-espionage campaign. This is the story of how your body's silent guardians keep you alive. The first line of defense: the fortress walls. Before the war can even begin, your fortress needs walls. Your body's first and most important line of defense is designed to simply keep invaders out. This is part of your innate immune system, the defenses you were born with. The most obvious barrier is your skin. It's a tough, waterproof shield, slightly acidic, making it as unwelcoming as a desert to many microbes. Your skin and mucous membranes are the fortress walls, encountering billions of organisms daily. But what about the gateways to the fortress, like your mouth, nose, and eyes? These have their own specialized guards. Your airways are lined with sticky mucus that acts like flypaper, trapping airborne pathogens. Tiny hairs called cilia are like a constant cleaning crew, always sweeping this mucus, and it's trapped invaders, up and out. Your eyes are protected by tears, which aren't just water. They're an antiseptic wash containing powerful enzymes that destroy bacteria. And your stomach is a death trap, an acid pit so strong it can dissolve most pathogens that you swallow. These are your walls, your moats, and your gatekeepers. Simple, yet incredibly effective at stopping the vast majority of infections before they start. But no fortress is truly impenetrable. A small cut, an overwhelming number of inhaled viruses. Sooner or later, something gets through, and that is when the real war begins. The innate immune system, the rapid response team. The moment a pathogen breaches the outer walls, it triggers an alarm. Damaged cells release chemical signals that act like a flare fired into the sky, screaming invasion. This is where the second part of your innate immune system kicks in: the rapid response team. These are your frontline soldiers, a collection of white blood cells always on patrol. They are like guard dogs that attack any stranger on sight. They don't care what the invader is, only that it's not supposed to be there. Meet the first player, the phagocytes, which literally means eating cells. The most common type are neutrophils. They're the most abundant type of white blood cell, and your body is a massive barracks, producing a staggering 100 billion of them every day. They have a short lifespan in circulation, with some studies suggesting about 5 days, because they're designed for one-way missions: seek and destroy. They are the first to arrive at an invasion, swarming the area, engulfing pathogens, and digesting them with toxic enzymes. If the invaders are too numerous, the heavy hitters arrive, the macrophages. These are the larger, more durable big eaters. They're like the battlefield medics and intelligence officers rolled into one. They not only consume dozens of pathogens, but also act as cleanup crews, clearing away dead cells. Crucially, they also gather evidence, preparing intel for the special forces. This entire battle is what you experience as inflammation. The redness, swelling, heat, and pain are all signs of the war. Blood vessels widen to rush more immune cells to the fight, causing redness and heat. The area swells as the battlefield is flooded with reinforcements. Even a fever is a deliberate strategy. By turning up the thermostat on the whole fortress, the immune system slows down the enemy's ability to reproduce and makes your own soldiers fight harder. For most everyday threats, this rapid, overwhelming force is enough. Calling for backup: the special forces. But what happens when the invasion is too big, or the enemy is too clever? What if a virus hides inside your own cells, like an enemy agent in civilian clothes, invisible to the patrols? When the frontline soldiers are overwhelmed, they don't give up. They call for backup. They send the intel they've gathered to headquarters, requesting the most elite, intelligent, and deadly force in the entire immune system. This is your adaptive immune system. Unlike the innate system, this branch isn't born ready, it learns. It's slow the first time it meets a new enemy, but it's incredibly precise, and most importantly, it remembers. This system relies on two types of elite soldiers, T cells and B cells. The story starts when an intelligence officer, like a macrophage, presents a piece of the invader, an antigen. Think of the antigen as the enemy's flag or uniform. The macrophage carries this flag to a military command center, like a lymph node, and shows it to a special kind of T cell, the helper T cell. Helper T cells are the generals of this war. Once a general recognizes the enemy's flag, it activates, rapidly multiplies, and starts issuing orders, called cytokines, to coordinate the entire Special Forces attack. The SWAT team, killer T cells. The first unit mobilized is the cell-mediated response, led by cytotoxic T cells, or killer T cells. Think of these as a SWAT team, trained to find and eliminate your own cells that have been compromised and turned into enemy factories. Their training, which happens in an organ called the thymus, is intense. They're tested to ensure they recognize enemy flags, but more importantly, that they won't attack your body's own healthy cells. This process prevents friendly fire or autoimmune disease. As we age, the thymus shrinks, and this training academy becomes less effective, which is one reason older individuals are more vulnerable to new infections. Once a killer T cell is activated by a general, it's released with one mission: hunt for any cell waving that specific enemy flag and destroy it. The weapons factory, B cells and antibodies. The second unit is the humoral response, which is all about creating custom-made weapons. The helper T cell general also activates B cells. Each B cell is a potential weapons factory, capable of producing one unique weapon, an antibody. When the general gives the order, the right B cell transforms into a plasma cell, a factory that goes into overdrive, churning out thousands of antibody molecules every single second. These antibodies flood your system. They don't kill invaders directly. Instead, they are like smart handcuffs or GPS trackers. They swarm the pathogens, binding to them so they can't infect more cells. This also tags them, painting them as glowing targets for the big eater, macrophages, to easily find and eliminate. Victory and lasting memory. Together, the killer T cell SWAT team and the antibody swarm are an unstoppable force. The T cells eliminate the enemy factories, your infected cells, while the antibodies handcuff and tag the invaders out in the open. This battle can take several days, which is why you feel sick. But eventually, the adaptive system wins, and the infection is cleared. The war is won. But the most incredible part isn't the victory, it's what happens next. After the fight, most of the specialized B and T cells die off. But a special few remain: memory T cells and memory B cells. These are the battle-hardened veterans of the war. They don't fight, but they continue to patrol for years, sometimes a lifetime, carrying a perfect memory of that enemy's flag. If that same pathogen ever invades again, these veterans are ready. They don't need to wait for orders. They recognize the enemy immediately and launch a response so fast and powerful, the invader is wiped out before it can even establish a base. You might not feel a single symptom. This is immunity. It's why you usually only get chickenpox once, and it's the principle behind vaccines. A vaccine is like giving your special forces the enemy's battle plans and a picture of their flag before the war has even started, letting them build an army of veterans without ever having to fight. Your ever-vigilant guardian. From the moment you are born, this two-part defense system is working tirelessly. Your innate immunity acts as the police on the beat, a blunt and immediate force that handles daily skirmishes. Your adaptive immunity is the intelligence agency and special forces, learning, strategizing, and remembering every major threat. Though individual memory cells are part of a dynamic population, the collective memory can last for decades, providing long-term protection. This intricate network, from the physical barrier of your skin to the chemical signals in your blood, from the brutish macrophages to the hyperspecific antibodies, all operates in the background. It fights and wins thousands of battles on your behalf, without you ever needing to know. It is the reason you can survive in a world teeming with things that could harm you. It is your silent, ever-vigilant guardian, a testament to the incredible, awe-inspiring complexity of the human body. The immune system is a universe of complexity, and we're discovering new things about it every day. If you found this journey into your body's hidden world fascinating, subscribe for more explorations into the science that makes us who we are.